Hello my dear students of standard 9. Today we will discuss about the simple pendulum. Now what is simple pendulum? Simple pendulum, it consists of a heavy point object suspended freely from a rigid support by a weightless inextensible string. This is the definition of simple pendulum. It consists of a heavy point object suspended freely from a rigid support by a weightless inextensible string. Now this is a theoretical pendulum. Simple pendulum is a theoretical pendulum because practically we cannot fulfill these things. This definition cannot be fulfilled in the laboratory because you see it consists of a heavy. It should be heavy. Heavy means it should be big and the density of the object should be more. And at the same time heavy point object. It should be point. Point means what? Which has no dimension, no length, no breadth, no height. It is very small. So very small point object and at the same time should be heavy. How is that possible? It's not possible at all. Again, suspended freely from a rigid support. Now nothing is 100% rigid. We will not get 100% rigid subject. So this is difficult to attain, rigid support, 100% rigid support by a weightless inextensible string. Now how the weight of a string will be zero? How will you take a string with zero weight? Even electron, proton, atom has weight. String, we will have to take a string which has no weight. So that is not possible, isn't it? So inextensible, a weightless, again inextensible string. Inextensible. Now everything is elastic. Nothing is 100% rigid. If you suspend some weight at the end of a string, it will be extended more or less. So you cannot take inextensible string. So this is difficult to attain in the laboratory. That is why this is a theoretical pendulum. We cannot attain this in the laboratory. So this is the definition of simple pendulum. Then you should know some of the definitions. Now what is the effective length of the pendulum? Effective length of the pendulum is the length, the distance between the point of suspension, this is the point from where the pendulum is suspended, point of suspension to the center of gravity. So this is point of suspension, this is CG of the pendulum, center of gravity. So the distance between point of suspension or the length between the point of suspension and the center of gravity of the pendulum is known as effective length. It is represented by L. Clear? This is the effective length of the pendulum. Then oscillation or vibration. One vibration means this A is the mean position. Mean position is the point about which the pendulum vibrates. So A is the mean position. Now one vibration means one to and fro motion. It will start from A, will move to B, then B to C, then C to A back. So that is one vibration. Or you can say, you can start from one extreme and say from B to C, C to B back. So that is one vibration or a complete oscillation. Then you should know what is time period of the pendulum. The time period of the pendulum is the time taken by the pendulum to complete one vibration. That is time taken to move from B to C, then back from C to B. That is known as time period. It is represented by T, capital T. That is time period of the pendulum. Then frequency of the pendulum, it is represented by small f. Frequency is the time taken for one complete oscillation, or it is 1 by T. Time taken for one complete oscillation is the time period of the pendulum. Now frequency of oscillation is number of complete oscillations made by the pendulum in 1 second. Pendulum is making how many complete oscillations in 1 second? That is frequency of oscillation. So frequency is equal to 1 by T, and the unit of frequency is hertz. H-E-R-T-Z, unit of frequency is hertz, or in short you can write Hz. Hertz is the unit of frequency. Clear? Now we'll see this time period of the pendulum depends on what factors. Time period of the pendulum depends on what factors. Now time period depends on two factors, or you can say two laws of simple pendulum. Now the first one is time period is directly proportional to the length of the pendulum. Time period is directly proportional to length of the pendulum, square root of length of the pendulum. Time period is directly proportional to length. If the length is more, time period will be more. Then second one is time period is inversely proportional to the square root of acceleration due to gravity, small g. This is acceleration due to gravity. Time period is inversely proportional to acceleration, square root of acceleration due to gravity. If the acceleration due to gravity is more, time period will be less. If acceleration due to gravity is less, time period will be more. Now combining these two, you can write the relation between T, L and G. So T is equal to 2 pi square root L by G. T is equal to 2 pi square root L by G. This is the formula for time period. Time period is equal to pi. Pi is a constant, you know. Its value is how much? 22 by 7. So 2 pi square root L by G. This is time period of the pendulum. So time period is directly proportional to length. Time period is inversely proportional to gravity. Now if you plot a graph, time period versus this L versus T square. This is L, this is T square. If you plot a graph, the nature of the graph will be this. It will be a straight line. Time period and T square. The graph will be like this. Now you will be asked to find from the formula, you may be asked to find any one of these three. T, L and G. There are three variables. So they will give you any two and will ask you to find out the other one. They will give you L and G, will ask you to find the time period. They may give time period and acceleration due to gravity and will ask you to find the length. Or you, in the laboratory, we can use this simple pendulum to find the acceleration due to gravity at a place. So in Varampur, if you want to know what is the acceleration due to gravity, we'll set up the pendulum in the lab, and for a different length, we'll find out the time period, and using this formula, we can find the acceleration due to gravity at Varampur. So problems may be asked based on this. Any two variables will be given, and the third one will be asked to find out. Clear? Then you should know what is seconds pendulum. Seconds pendulum. Seconds pendulum. Now seconds pendulum is a pendulum, simple pendulum, for which the time period is 2 seconds. T is equal to 2 seconds. If the time period of a simple pendulum is 2 seconds, that is known as seconds pendulum. If time period is 2 seconds, that is known as seconds pendulum. And the effective length of the seconds pendulum will be approximately 1 meter. That is 100 centimeter. If you take G value 9.8, G value 9.8 and T is equal to 2 and calculate L, it will come 99.9 something. So around 100 centimeter. That is 1 meter. The length of the seconds pendulum is approximately 1 meter. Clear? Understood, children? So what is simple pendulum? Definition of simple pendulum. Then definition of effective length. Then one vibration. Then time period. Then frequency. Then time period depends on what factors? Two laws. Time period depends on length of the pendulum, effective length. Then time period depends on gravity. Now relating this, what is the formula? Then what is seconds pendulum? Clear, students? So based on these problems will be asked. Understood? So thank you.